So this programmer is working on his computer, right? Clean install, and he set up his development environment from scratch, like we all do. And he started coding in Cursor, which is an AI-based editor. You probably heard of it. It's a fork of VS Code. So this guy is writing his code. Everything seems normal. Just another day in the life of a blockchain developer. And here's the thing. This guy is not a rookie, right? He isn't a guy who would click on a spam pop-up that says, "You've won $1 million." No, this is a guy who works on cryptocurrency daily, okay? Someone who knows the crypto world. So a few days pass, and then he goes to check one of his crypto wallets, and his stomach drops. $500,000 gone. It just vanished. And it's not like a small test transaction that went to the wrong address. No, this is $500,000 of cryptocurrency transferred out of his wallets without his knowledge. So as you can imagine, after he gets over the shock and all the phases of emotions that you would expect someone in that situation to go through, now he starts thinking, how did this happen? Did his private key get leaked? Did someone steal his seed phrase? But this guy is careful, right? Most experienced crypto developers are careful. His computer has had a fresh install, only a few days old, fresh Windows install. He hasn't visited any sketchy websites. He hasn't downloaded any cracked software. It's just the basics, his development tools, his browser, and his code editor. So in his analysis, nothing flagged as suspicious. So in June 2025, this guy reaches out to a cybersecurity company called Kaspersky. So he gives them access to everything, right? His system, his logs, his entire setup. And they take a look at this and manage to find the culprit eventually. So this culprit was actually a small piece of code that was executing right inside his Cursor IDE. But this wasn't code that this guy happened to write. Okay, so let's take a step back and talk about how we've got here. We probably already know that the way we write code has fundamentally changed these days, right? We've gone from typing every single character ourselves to having AI assistants inside AI-powered editors that can basically wipe code for you, okay? So Cursor is one of those AI-powered editors that has been gaining a lot of traction. I'm sure you would have probably heard of it. It's essentially a fork of Visual Studio Code, which is Microsoft's incredibly powerful IDE, a code editor. But Cursor has AI capabilities baked in. Okay, so the company that founded Cursor decided to fork the open source VS Code project so that they have more control over what features they develop and how they can build good integration of AI into the software rather than just like a layer or an additional plugin, which can kind of be limiting in what kind of features that they build. Okay, so remember this, because this is going to become really important for our story. Okay, the developer who got his money stolen was using Cursor and not VS Code. Okay, and a whole lot of reasons why this is important, I'll come back to in a bit. So Kaspersky, the security company that gets the disk image, right? They start digging into it. Now, when you do this kind of forensic analysis on a compromised system, you're basically playing detective, right? You're looking for anything that shouldn't be there, any file that seems out of place, or any process that's acting suspicious. So these guys find something. In the user's profile directory, there's this file called extension.js, and they find really malicious code in it. So the code itself is surprisingly straightforward, right? It reaches to a server called angelic.su, and it downloads a PowerShell script. Just pulls it down, an executable script, and then it executes it. No questions asked. So whatever code is in that script that's uploaded to that server somewhere now has the ability to execute on this machine with full execution access. Okay, now what is the script and how did it get here? Well, the script is sitting in a very specific location, right? Inside the Cursor's extension folder as a part of something called the Solidity language extension. For those of you who don't know, Solidity is a programming language that you use to write smart contracts in Ethereum. So for example, if you're a Java or a Go developer working in VS Code, you download a Java language extension or a Go language extension to run in VS Code, right? To provide you with language capabilities. So this is similar. Here is a blockchain developer working on crypto. So he downloaded the Solidity extension to help with programming. That makes perfect sense. You would want syntax highlighting, maybe some auto-completion, error checking, all that standard stuff that you do to make your coding easier. But when the researchers actually opened up this extensions.js file, oh boy, this isn't providing any language support. This isn't highlighting any syntax. What is it doing? Well, first of all, this code runs every time the extension loads. Well, every time the developer opens Cursor to work on his projects, this malicious code is silently doing its thing in the background, right? It's downloading and executing a script from the remote server. This PowerShell script that it downloads, well, it first checks if you have something called Screen Connect installed on your machine. Okay, Screen Connect is actually legitimate software. It's a remote access software. It's the kind that IT departments use to help like remote employees with tech issues, right? They can connect and do remote access. So this script, this PowerShell script, first checks if the software is already available on your machine. If not, it helpfully downloads it and installs it for you, right? Except that this version is now configured to talk to the attacker's servers. Now think about this for a second. Now the attacker has remote access to your machine. They can see your screen, they can control your mouse and keyboard, they can browse your files, and in the case of this blockchain developer, they can access his wallet, passwords, seed phrases, everything. And worse, what has actually happened is through Screen Connect, the hackers have actually uploaded more scripts to the machine. There are more malware that specifically hunts for cryptocurrency wallets and browser passwords. Now the attackers basically have complete access to the machine with really no fault of the developer. But now you might be thinking, well, yeah, this developer probably pulled in like an extension from some weird place. Of course, you can't really predict what the extension will do unless you get it from a proper authorized place, right? But what if I told you that the developer did nothing wrong? He opened Cursor, went to the extension marketplace in Cursor, and downloaded an extension that showed up there. Clearly, the developer didn't do anything wrong. You and I would have done the same thing too, right? And you and I could have been a victim of an attack just as easily. Let's think about this. How is this possible if the developer actually installed an extension from Cursor itself and from the list of extensions that have been published in the marketplace? How could a malware possibly get in? So it turns out that there were multiple extensions in the Cursor extension marketplace when you search for Solidity. Okay, so when a developer searched for Solidity in the Cursor extension marketplace, it wasn't just looking at one extension. There were multiple results. The malicious extension was one of the results, and it looked completely legitimate. The description, you look at the description, right? It promised all the right things, right? Syntax highlighting, code snippets, debugging tools, everything that a Solidity developer would want. But here's the thing, the attackers didn't even bother writing their own description. They literally copy-pasted the entire thing from the legitimate Solidity extension that already existed in the marketplace. Now, at this point, you're thinking, well, come on, Kaushik, I wouldn't fall for that. Of course, when I'm comparing two similar extensions side by side, I'm going to go with which one has the more downloads because that's likely to be more legitimate, right? If it has a large number of downloads, probably legitimate. Smaller number of downloads, fishy, I don't want to install. Okay, well, firstly, one has 61,000 downloads, the other has 54,000 downloads. Which one would you pick? Okay, the legitimate one has 61,000 downloads and the malicious one has 54,000. But you can see that it isn't obvious. They're pretty close, okay? Unless you see the 61,000 downloads, if you're just looking at the malicious one with 54,000 downloads on its own, it looks pretty legit, right? Okay, secondly, when our developer searched for Solidity and the malicious extension showed up, it showed up fourth in the list of search results. What about the legitimate one? That showed up eighth in the search results. Wait, what? How does an extension with fewer downloads rank higher than the real one? Well, it turns out Cursor uses an extension marketplace called OpenVSX. I'll have more to say about this soon. So what this marketplace does, it just doesn't sort by download count. It uses something called relevance algorithm. And this algorithm looks at multiple factors. Download count, yes, but also things like when was this extension last updated? What is its rating? Is it verified? And the attackers knew this. They gamed the system. They updated the fake extension on June 15th, 2025. The legitimate one, last updated date, May 30th. So that 2-week difference, that was enough to boost the fake extension higher in the search results. So our developer, he's scrolling through the list of results. He sees an extension near the top with tens of thousands of downloads, 54,000 to be precise. The description looks professional Everything checks out. He clicks install. So it so happens that this extension doesn't work at all, right? It provides zero functionality, no syntax highlighting, no code completion, nothing. Okay, so the developer has looked at that and gone, well, this is buggy. It isn't working. Maybe incompatible with my current setup. So he makes a mental note, okay, I'll troubleshoot this later, and he moves on with his work. So meanwhile, this extension.js that's downloaded is doing what it was actually written to do, right? Every time it opens Cursor, it's reaching out to that server. It's downloading that PowerShell script. It's setting up this backdoor. And the extension is literally doing just this. It has zero other functionality. So this is what the code does. This is the entirety of the extension. It's the complete functionality. All it does is fetch a script and execute it. But wait, this gets worse. So this extension was actually caught, reported, and removed from the marketplace on July 2nd. Just 1 day later, the attackers came back. This time, they've come with a new extension, same name as the legitimate one, Solidity, but this time they did something else. They actually inflated the download count to 2 million. Remember, the download count for the original one, 61,000. Okay, now picture this. You search for a Solidity extension, you see two that look identical, same name, same description. One has 61,000 downloads, the other has 2 million. The developer and names look similar too, okay? One is this, and the other is this. Notice the difference? This one is a capital I instead of a lowercase l. And in Cursor font, they look exactly the same. Okay, so now put yourself in this position. Which one are you going to trust? The one with 2 million downloads, right? That's what everyone seems to be using. That must be the safe choice. So all that the attackers have to do is to set this and forget it. Now the whole operation is automated. Okay, the attackers probably compromised hundreds, maybe thousands of developers this way, right? Just this one guy happened to have $500,000 worth of crypto on his machine. And remember, this all started with what seemed like a routine extension install, something that developers do every day, something you've probably done dozens of times without thinking twice. I know I have. And this is what makes the attack so insidious, right? It exploits like this core trust mechanisms that we normally rely on, right? We look at download counts, we look at user ratings, we look at good descriptions, right? This is what lets me make a decision, and all of this can be faked. All of this was faked. All right, so remember how I mentioned that Cursor is a fork of VS Code, right? And how that detail was going to become really important. Okay, let me explain why. You see, Visual Studio Code, like the original Microsoft one, you use it when you go to the extensions tab to download an extension. You get your extension from what's called the Visual Studio Marketplace. This is Microsoft's marketplace, right? This is a marketplace that's hosted by them, managed by them. It's their store, it's their ecosystem. And Microsoft has made it very clear that this marketplace is for Visual Studio products only. Because there are several reasons I'm not going to get into, but mainly it's a service that they are paying to maintain and host, and they're offering that service to their users, which is fair. Just like an iPhone app store offers apps to the iPhone, and you wouldn't expect an Android phone user to be able to pull up apps from an iPhone app store. Remember this distinction. The Visual Code IDE itself is an open source project, okay? The IDE code is open source, but the store is proprietary and owned by Microsoft. Now, the thing about the Cursor IDE is that it's a fork of VS Code. Since it's an AI-based IDE, right? They've decided to fork VS Code and build features on top of it so that they can control the integration of the AI features into the IDE. The overall idea is they can build better features, they can own the entire code that they're working on, which is fair. But now the problem is that they cannot use the Microsoft marketplace. Neither can any of these VS Code forks out there, by the way. This is not specific to Cursor. And there are quite a lot of them. There's Codium, there is Gitpart, there's Windsurf, there's a whole lot more, right? All of these are based on VS Code's open source code, but they're not Microsoft products, so they cannot use the official Microsoft extension marketplace. But they need extensions too. So what do? They use something called OpenVSX. It's like a community-run alternative to Microsoft's VS Code extension marketplace. It's almost like a mirror of the Microsoft's marketplace. So when the fork needs to install an extension. So that fork can essentially point to this marketplace and install the extensions in a very similar way in which how VS Code users install extensions from the Microsoft marketplace. Now, I want to be very clear here. I'm not saying that this is wrong or somebody is a bad guy or a good guy. I'm just explaining the situation as it is today, right? The editor is open, but the ecosystem, the extension ecosystem in Microsoft is closed. And that creates a gap. And this is a gap that OpenVSX tries to fill. Now, let me tell you why this matters for our story. Okay? The Microsoft marketplace, they have teams of people reviewing extensions. They have automated security scanning. They have policies. They have procedures. Is it perfect? No, definitely not, right? Malicious extensions have slipped through there too, but it's a little more stricter level of gatekeeping. But OpenVSX is run by the Eclipse Foundation with a much smaller team. And here's the thing. They're trying to be the open alternative. The whole philosophy is about being accessible, being community driven, having fewer barriers to entry, which is a beautiful ideal, but you see where this is going, right? Lesser gatekeeping means it's easier for developers to publish extensions. It's also easier for attackers to publish fake ones. Now, think about it from the attacker's perspective, right? If you're trying to distribute malware disguised as an extension, where would you rather operate? In Microsoft's heavily monitored marketplace or in something that's a little more open and less resourced alternative that's trying to serve everyone else? Now, again, I'm not saying that OpenVSX is bad or that they're not trying. They are trying, okay? When the Solidity malware was reported, they took it down pretty quickly. But then the attackers came back the next day with a new one, right? It's almost like playing whack-a-mole, right? You end one, another one shows up. So anyway, setting all this philosophical discussion about which is better, what they need to be fixed, and let's set that aside. The fact of the matter is our blockchain developer was using Cursor and he went to install an extension from the open marketplace. And if you are using Cursor or any of those gazillion VS Code clones out there, well, guess what? You're also installing an extension from this open marketplace. The worst part is this affected developer did everything right. He used a legitimate editor. He went to the official extension source for that editor. He checked the download counts. He installed what looked like a professional extension. So the system has failed him and not the other way around. Let's zoom out for a bit, because what actually happened to our developer, it's not just a bad extension or one unlucky install, right? This is something a little more fundamental in how extensions work. And once you understand this, you'll realize why this attack was so effective and why it could happen again tomorrow. So I've actually written VS Code extensions for almost a couple of years in my professional career, right? I had to do it on the job. And I can tell you from my experience, this is a problem in general. Think about what an extension is, right? When you install an extension in your code editor, what are you really doing? You're basically inviting a piece of software to live inside your development environment. Not just live, you're actually giving it permission to do, well, basically anything. Let me put it this way. When you're coding, what do you need your editor to do? Read your files, obviously. Write to them, yeah. Create new files, yes. Delete files, yes. Run commands, execute files. Access your terminal. Perhaps connect to the internet to download files. You see what's going on? And here's the thing. All this stuff, your extensions need to be able to do as well. Okay, so depending on the extension, the syntax highlighter, it needs to read your code to understand what to highlight. Formatter, it needs to read entire files and write entire files. Snippet manager, it needs to inject code wherever your cursor is. So we've got this fundamental problem. Extensions need power to be useful. They can't do their job inside a sandbox. They need real access to your real files and your real system. But that same power makes them dangerous. Now, you might be thinking, well, my browser has extensions and those seem pretty safe. Well, you're right. Browsers do have extensions. And here's the thing, the browser extensions actually do run in a sandbox. They can only access certain APIs. They only touch certain parts of your browsing experience, right? When the browser extension wants to read, for example, he wants to read all data on a website, it has to specifically ask for that specific permission. And you see that pop up, right? This extension wants to read and change all data on blah, blah, blah.com. But even if you were to give it all access, it still operates in a sandbox and it doesn't have complete access to your computer. But IDE extensions, completely different story. So basically what we have here is the ease of use of downloading a browser extension from some marketplace combined with the power of an application that would otherwise, it would require admin access to even install on your machine. So if you had to install the Solidity extension, the malicious one, it didn't ask for any permissions. It couldn't ask for permissions because the permission is basically everything, access to run any code that it wants. And the code to run this could basically be just a few lines of JavaScript. Do you remember that extension.js we talked about, the one that downloads a PowerShell script? That's not some complex hacking technique. That's just JavaScript doing what can basically be done in a Node.js environment, which is what the VS Code extensions run on. This is literally all it takes. You get the child process, execute PowerShell, and you download some script. That's it. 2 lines of code, and now your extension can run any command on your system. This is for Windows because it's PowerShell, of course, but you can write something similar for Mac or Linux. So we've built this entire extension ecosystem based on trust. We trust that the extension that says that, okay, there's a syntax highlighter is actually a syntax highlighter. We trust that the developer who publishes it isn't malicious. We trust that no one has compromised their accounts or uploaded a malicious update. And for the most part, this trust pays off. Most extensions are fine, and most developers are honest. The system works until it doesn't. All right, so here's something that will blow your mind. Now, if you think about all this and you want to protect yourself, you might think of an obvious solution. Well, I'm just going to use open source extensions that have their code published on GitHub and the code is visible for everyone to see. Transparency, right? Anyone can look at the code, anyone can verify what it does. If there's something malicious, someone will spot it and the community will patch it. That's the whole point, right? And that's true for the source code. But here's the thing. What you install on your computer isn't source code. When you install the extension, what you're installing is a compiled, packaged, ready to run version of the extension. And there is a gap there. If you wanted to check what an extension does, where would you look? Let's say it's an open source extension. The extension marketplace usually has like a link to the GitHub repository. Okay, sure, but that's actually the repository. It's not code running on your machine. How do you verify that? And that's the thing about the build process, right? The developer writes the code. They run it through various tools like minifiers, bundlers, compilers. They package it up to an extension format, and then they upload it to the marketplace. Now, let's say I'm a malicious developer creating a legitimately useful extension. I publish that open source on GitHub. It's clean. People can review it. Maybe security researchers can even audit it and give it a thumbs up. But when I package it for distribution, add a little extra something, right? A tiny piece of code that phones home or waits for a special date or activates on a certain condition. The source code on GitHub, still clean. The code running on thousands of machines, not so much. Do you understand? And this isn't theoretical, right? This has actually happened over and over again. And it's not just with VS Code extensions. It happens with NPM packages, Python libraries, browser extensions. The source looks fine, but the distributed version, that's where the malware lives. And in the case of our blockchain developer, this wasn't even the case, right? The attackers didn't even bother with this. They literally published the malicious code directly, but they could have been sneakier. They could have maintained a clean GitHub repo while distributing the infected versions. And who would know? Now, technically, yes, there are ways to verify this stuff, right? You could build it yourself from the source. You could use cryptographic signatures, etc., etc. But let's be real. How many people are actually going to do this? You're not going to do this. I'm not going to do this. We are just going to click install and we're going to get on with our lives because we have stuff to do. So where does this leave us? We've got extensions that need system level access to function. And we've got the marketplace with varying levels of oversight. We have source code, which may not match what's actually running on the machine. And we've got attackers who understand all of this and they're willing to exploit it. Kind of a bleak picture, right? But here's the thing. You can't stop using extensions, of course. These are tools and we need them for the job. Sure, some of them might be dangerous, but most of them are incredibly useful. The trick is learning how to use them safely. So I'm going to share with you some practical strategies, right? Real things that you can do starting today to protect yourself. Okay, the first thing is a really neat trick that anyone using Cursor or any of these other VS Code forks should do. You know how I talked about the Microsoft's marketplace being a little more heavily vetted, right? When you install extensions from the Microsoft marketplace into VS Code, it's likely to be a little more safer, okay? And you can actually use that to your advantage. So here's what you can do. You can install VS Code, the official one, alongside your preferred fork. So you're using Cursor. Also install VS Code. And when you need a new extension, first install it in VS Code from the Microsoft Marketplace. Okay, test it out. Make sure it does actually what it claims to do. And then, only then, bring it over to your forks. Okay, a lot of these VS Code forks have like a migration feature, which allows you to port extensions and even preferences from VS Code into them. For example, you start up Cursor, you have a way to import all of your preferences and extensions from VS Code into Cursor. So if you have installed the extensions in VS Code and you're porting that over to Cursor, you can be sure that you're installing the right extension in Cursor and not a malicious one. And the reason this works is because when extensions migrate, right, they're matched by ID, right? Each of these extensions has an ID. So if you've got a legitimate Solidity extension, in this case, you have got a legitimate extension in the Microsoft Marketplace, it will look for the exact ID in the OpenVSX Marketplace. And the fake ones, they may have similar names, but they won't have the same ID. So it's more secure. It's likely to be more secure. Okay, that's the first thing. Secondly, remember how our developer noticed that the extension didn't work, but we figured they'll debug it later? That's a red flag. Okay, if an extension promises something, but if it doesn't deliver it, just uninstall it immediately. I don't care if it has 1 million downloads. If it's not working, it's at best buggy, and at worst, it's malicious. So investigate right away or remove it right away. And here's another thing. Check the publisher of the extension. I mean, really check. Don't just glance at it, right? Click through their profile, see how long they've been publishing extensions. What else have they made? Is it just a one-off random extension? Or do they have like a portfolio of extensions that make sense, right? Our attackers used a name with like a capital I to substitute an L to kind of make it confusing, right? This is something that you can catch only if you are paying attention and looking at the publisher. Let's talk about timing. Okay, new extensions are always risky. It's tempting to be an early adopter to try the new cool thing, but when it comes to extensions that have access to your entire system, maybe just wait a bit, right? Let other people be the guinea pigs. Let them try it out. A legitimate extension that's been around for 6 months or a year, it has had time for people to try it out and for problems to surface, right? It's not perfect. Even that could be a problem, but it's better than nothing. And the general advice that I would give to wrap this all off is compartmentalization. If you're working on sensitive stuff, maybe you're dealing with cryptocurrency, maybe you're working on proprietary code for your company and you've got access to production servers, use a minimal setup. Install only the extensions that you absolutely need, not the ones that are nice to have, only the ones that you literally cannot work without. And compartmentalize. Separate your work stuff from your personal stuff. If you've got $500,000 in like a non-custodial cryptocurrency wallet on your machine, you really shouldn't be installing anything else on it. You got to match your security practices to your risk level. Okay, when you have that much money on your machine, it's a different threat model as opposed to like you have like a computer where you're just learning to code on the weekends, right? Know what you're trying to protect and adjust accordingly. And in general, I think we need to change how we think about trust in software. The older model was simple, right? You got software from a company in a box, you installed it, and something went wrong, you knew who to blame. But we are in this kind of weird space where we are running code from like random GitHub users that we've never met, and it's maintained by people who are kind of doing it for free in their spare time, right? And it's being distributed through marketplaces that's run by basically volunteers. It's amazing. It works great for the most part, but sometimes it doesn't work as well because these attackers, they're not going away, right? If anything, they're getting more and more sophisticated. those inflated download numbers. There's this thing called typo squatting, where they catch any typos in the searches. They have fake descriptions. This is just the beginning. As more and more money flows through the software ecosystem, more developers kind of hold these valuable assets on their developer machines, right? These attacks will only intensify. But now you're making informed decisions about your security, and that's really all that we can do. Stay informed, stay cautious, but don't let fear stop you from building great things. Maybe just be a little more careful about which extensions you use when you're building those great things.